Hello everyone, welcome to my channel. So today we are going to discuss derivative of power functions including the chain rule. First of all, we will understand what is a power function. Power function is a function which has this form, x to the power n. So this x is called the base and the n is the power. So now if you want to find the derivative, the differentiation, the first derivative of this power function which is x to the power n, the answer would be nxn minus 1. So everybody knows it. So now this is called the differential operator. So x is the variable associated with the differential operator and the base of the function is x. So then as the output, you get xn minus 1, which you have the same base as the function. Now what we have to observe here is this. The variable associated with the differential operator is x and the base of the function is x and the output has x. So we can use this rule if these three things are going to match each other. For example, if you have ddx of x to the power 5, so then what we have to look is the base of the function and the variable associated with the differential operator x. So then you can directly use this rule. So n would be 5 in this case. So 5 x to the power 4. This is very easy. Now, if I extend this idea, if I get ddx of 5 x to the power 3, for example, we can take this 5 out. So you can say 5 ddx of x to the power 3. So why we can take this 5 out? Because 5 is a constant, so all the constants can be taken out. Now here we can use the rule what we have already talked about. So that would be 5 times 3 x to the power 2 and the answer would be 15x2. Second example, if I get ddx 6x to the power 4 plus 2x to the power 2. Now here we can see the constant rule and the summation rule has applied here. So you can take this 6 out. So I'm going to directly write 6 ddx of x to the power 5. Sorry, x to the power 4 here. And then we have 2 here. So I'm going to take that 2 out. So 2 ddx of x to the power 2. Now what you can see, here we can use the rule. Then that would be 6. And once you apply the rule, that would be 4 x to the power 3. So we have to be careful here. Plus, you have 2 here. Now, if you use the rule, the answer would be 2 x to the power 1. So if you simplify this, this is going to be 24 x to the power 3 plus this is going to be 4 x to the power 1. So now we will try to understand if you have something like this, ddx x plus 1 to the power 2. Now we will understand how to get the derivative of this one. The variable associated with the differential operator is x and the base of the power function is x plus 1. So now this is the contradiction, right? So this is the contradiction. So now if you go back here, the base of the power function should be x and the variable associated with the derivative should be x so that you can have this output. If you have something else as the function, you can't do that. So that is what the first base case is talking about. Now in that case, what we do a small construction, and that is what I'm going to teach you today here in this example. What we will do, knowing that fact, I'm going to do this construction. I'm going to make x plus 1 here. So that will be the variable associated with the differential operator. And I'm going to keep the function. Then what I will do, I will sort of try to cancel what I have constructed. So that would be x plus 1. And then I'm going to put what I had before. Like this is the original one. So now you can see seemingly these two are canceling each other, right? So now if you look at this term, this is the variable associated with the differential operator. So this is the differential operator now. And this is the base of the function. So now you can see base of the function and the variable associated with the differential operator, they're matching each other. So that will tell you that you can use the base case number 1. So if you look at the previous example, if you have x over here and x over there, so the answer would be 2x to the power 1. So that would be 2x plus 1 to the power 1. I hope this is clear. So I'm talking about this term. Then I'm going to multiply with ddx of x plus 1. So ddx of x plus 1, that is very easy. So if I explain it more, you can use the summation rule. So if I use the summation rule, that would be ddx of 1. So we know this is going to be 1. Why? Because x to the power 0. If you use the power rule, and this is going to be 0. Why? Because the derivative of a constant is 0. So finally, our answer would be, from this part I get 1. So our answer would be 2 times x plus 1. So that would be our answer to that question. As our fourth example, we will try to differentiate this question. Suppose you have 2x squared plus 2x whole thing to the power 4. So now you can see this is a little complicated, but we have to stick with our basics. Now the variable associated with the differential operator is x. The base of the power function is this 2x squared plus 2x. So this is the power. So now the rule says the variable associated with the differential operator should be equal to the base of the power function so that you can use the rule. So what we will do, so we will try to construct this. So according to that construction, I'm going to put the base of the function here, and I'm going to copy the function. And then this is my construction. So I'm going to cancel that construction by writing that here. And I'm going to divide with the one we had originally, ddx. So now you can see this connection. So this is called the chain rule. This is called the chain rule. So this chain rule is a logical construction. Chain rule is a logical construction. So once you have this, the answer to this part would be 4 2x squared plus 2x raised to the power 3 times. So now we have to differentiate this part. So this part would be really easy. So let me write it down in this way. So I'm going to take this constant 2 out, and then ddx of x to the power 2 plus, so I'm using the summation rule. Again, I have 2 here. I'm going to take that 2 out. So ddx of x here. So now here, again, we can use the power rule. So that part would be 2x. And this one would be 1 because ddx of x would be 1. So combinedly, I can write 4 times 2x squared plus 2x whole thing to the power 3 times 2 times 2x would be 4x. Here you get 2. So that would be the answer to that question. Finally, we will get this question. This question is a little bit complicated. So we will try to tackle this question. So if you have x plus 1 to the power 2 plus x, the whole thing to the power 3. So if you want to differentiate this, we will do the same thing. So now you can see This would be the base first. This would be the base for the outer function. You can see these three over here. Now, we are going to use our base case number 1. So the construction would be D. Here I'm going to use x plus 1 to the power 2 plus x. So that is my base to the outer function. Then I'm going to repeat whatever I have as the function, 3. Now, logically, I'm going to cancel what I have constructed over here. And that is called the chain rule. Chain rule is a very logical thing that we have used in differentiation. So originally we have dx. So I'm going to put that. So this is what my chain rule. So chain, you know, chain is something connecting. So these two terms are connecting with this mathematical terms. So this is the mathematical term that is going to be connected with this term over here. So now from here, I can write, so the power is 3 here. So I'm going to use the base case number 1, the power rule, which is 3. Now we have to be careful. A lot of terms here, x plus 1 squared plus x. So this should be 2 here. So this part is done. Multiplied with, now here I can use the summation rule. So I'm going to split this, d dx, x plus 1 squared plus d dx of x. So we have to carefully put the bracket. So this is nothing but 1 that we know. Now, what about this? Can we use the power rule here? We can't use the power rule directly. Why? The variable associated with the differential operator is x. The base of the function would be x plus 1. So you have to construct it again if you want to use it. So what I will do, I will construct it in this way. And then I'm going to cancel that construction. Right? So I'm going to have dx over here. And this is the chain rule over here. So in this question, I'm using chain rule twice. Now, if you calculate this one, this would be 2x plus 1. It's going to be very easy. And then this one is 1. So this part is very easy. If you can see, you can split it. You can use the summation rule. And d dx of x is 1. d dx of 1 is 0. So this is going to be 1. Now, if you compile all of these, you get 3 x plus 1 to the power 2 plus x, the whole thing to the power 2, multiplied with, from this term, I get 2x plus 1. And then from here, I get 1. So it's going to be like this. So finally, you can write 3. So I can say this is 2x plus 2. So I'm not going to factorize it, but I will just write that 2x plus 2. Here you have x plus 1, the whole thing to the power 2 plus x, the outer bracket to the power 2. So that will be our final answer to that question. I hope you understood the power rule and the chain rule associated with that. And thank you for watching.